is near-patient testing or point-of-care testing. Basically, it's any testing that is not conducted in the core lab or a core-like lab. And if you think about where it's happening at the bedside, it's happening at the clinic, and in the patient's clinic. If we look at the total testing process, and you have seen that probably, it basically starts with the clinician perceiving a need for the test, and it ends up with a result that goes back to the clinician, and it's interpreted and used for patient care. This whole testing cycle, the largest part of errors that occur actually occur before the sample is put on the analyzer, basically in the so-called pre-analytical phase. Between 32 and 75% of errors actually happen in the analytic phase. And if you think about what is the best opportunity for improvement and reduction of errors in the core lab, basically that's the decreasing errors in the pre-analytic phase. Well, that's not the case when you think about the errors that occur in point of care. Data that exists so far indicate that most of the errors in the point of care testing happen in the analytical phase. And so why is it that we have so many errors in the pre-analytical phase in the core lab, and then a much lower number in point of care? First of all, the detection of pre-analytical errors in point of care is not so easy. And if you think about why, because often we do not have a visual of the sample that is put into the instrument or into the cartridge. And also, the analyzers themselves do not have a way to detect a sample quality error like our core lab instruments do. So when we think about pre-analytical variables, as you know, we can define them and separate them into two major buckets. First is the fixed group, and basically they're most often biological and absolutely beyond control of the phlebotomist or the laboratory. And then we have those that we call variable. They're technical and are within control of the phlebotomist, the laboratory, and to some extent, our nursing colleagues. So this is a kind of list of the most common variable pre-analytical factors that impact errors in this phase, and we can separate them into patient identification related, collection related, sample handling related, and those that happen in sample transport and storage. So quite a few listed here. So if we want to compare, how does that compare and contrast with the near patient and point of care testing, we can see that there's a smaller number of them, and so one could then think that there's less probability or less opportunity to actually have a pre-analytical error in point of care. If we look at the course lab specimen workflow, it is very complex, and as you can see, you can divide them into steps, and each step can be divided then into distinct sub-processes, and they can even be further analyzed, and there's components within each of them. So very complex. And why is that a problem? Well, whenever you have a complex process with a lot of handoffs, the likelihood and the possibility of creating an error at each handoff increases dramatically. So how does this look like in near patient testing and point of care? Well, it is much simplified. We have less steps, and so one could think, well, we have less opportunity for error. But I would argue that that's not the case. So if we look at the actual workflow of obtaining a specimen and then all the steps that happen from the time you collect a specimen to the time you put that specimen on the analyzer, actually, there are quite a few steps. So, for instance, let's take the collection of a specimen from an IV line. You have multiple options. First of all, you have to prep the IV line, and hopefully we'll do that for every type of process that you have. Now, you can collect it via a heparinized syringe for critical care testing, and you have to process that. You have to collect it, right? And then you have to mix and process and then dispense the sample in an anaerobic way, and hopefully don't put bubbles and microclots in there. You can if you want to do other kind of testing, let's say, for instance, in a handheld device for general chemistry. You can take an access device to connect the IV line, and then you can transfer it into a blood collection tube, and then you have to somehow transfer that specimen into a cartridge and then put it on the analyzer. Or you will collect with a syringe, and then you can transfer that blood using a transfer device into a vacutainer tube, and then, or an evacuated tube, and then, transfer that into a cartridge or an analyzer. So again, there's a lot of variability, and whenever there's a lot of variability, there's a lot of opportunity for error. So if you think about the major reasons for rejecting chemistry and hematology specimens, these are data from the mid 90s, and not much has changed. Most of the reasons for rejecting specimens in clinical chemistry is hemolysis, and the most common reason for rejecting specimens in hematology is clotting. We have not done much to improve that in this time that has passed. And here is a list of errors in the preanalytical phase that happen in stat laboratory testing. And as you can see, there's a whole slew of opportunities for that. And they come from different parts of the testing process. Either it's the type of a process that you use to collect the specimen, process it and transfer it and use the data that you obtain. Now, if we think about the preanalytical errors in point of care, we can divide them into four major categories. The first is test ordering. So how can we actually make an error where we can have either excessive or mistimed orders and actually get erroneous results? There is still a possibility to get an error if you basically do not identify the patient or the specimen correctly. And you can also have either an error at the point of collection, or you can have an error at the point of time where you enter the patient information into the actual instrument that is going to be used. Then we have the specimen collection errors, and those happen when we have inappropriate or inconsistent specimen types. If the volume of blood that is dispensed is wrong, or the application to the testing surface or the chamber is wrong, you can get those errors. And then, last but not least, there are specimen evaluation errors, like attributes that are compromising the patient ID or the collection quality that are not recognized. So what is the impact of these point of care quality errors on patient care? So in the first column, we have an actual score, what is actually happening. And then in the P score is what potentially can happen. And then 1 to 5 is the severity of the error and potential impact on patient. The 1 being the least harmful, and then number 5 being basically death. And as you can see, actually, we have relatively a low impact on patient care. However, there is actually a possibility to have some serious